Okay, pre-calc fans, today is we're looking at what's called the difference quotient. It's a form of the rate of change. Okay, remember, rate of change is simply slope. Okay, so here's your slope formula. Now, so what are we talking about here? So if I'm looking at my little curve here, here's x plus h, so that means the distance between x and x plus h is this h distance. Okay, the y value here is f of x, so whatever this x is, remember f of x based on the equation, and then the y value up here is f of x plus h. So, okay, so the ordered pair here is x comma f of x, and then up here the ordered pair is x plus h comma f of x plus h. So these are just your x, y, x, y. Okay, that's all, just fancy ways of writing them out. So now we're going to apply these ordered pairs in the form of slope. So we're going to find the slope of these to actually make what's called the difference quotient. So we're looking at the ordered pairs, x, comma, f of x, and x plus h, oops, let me not put that in. So x plus h, comma, f of x plus h. There. So we're going to fill in the slope formula. So I'm going to use this as my y1, x2, y2, and then this will be my x1, y1. So it's f of x plus h minus f of x over the x plus h minus x. So all I did was fill in my slope formula based on these ordered pairs. Okay? Based on these ordered pairs. And now I just have to clean up the mess. So there's nothing to clean up here. And what happens with these x's? That's right, they cancel out. So I have f of x plus h minus f of x all over h. This right here is called the difference quotient. Okay? This is the idea of the title of our course, Pre-Calculus. Okay? This idea right here, this difference quotient, is the concept of us when we talk about derivatives in your calculus career, and when we do our problems. So this difference quotient is our precursor to what a derivative is. This is the definition of a derivative. It's our precursor to calculus. All right, so let's look at what this all means. So it says express the difference quotient in its simplest forms. So f of x is equal to 2x minus 3. So remember, f of x, there's f of x, x plus h. Well, what does that mean? Well, x plus h. Remember, anything inside the parentheses goes into the x spot. So it's f of x plus h minus f of x all over h. So your f function, there's the f function. Here's the equation, here's the variable x, so whatever we put in here has to go in there. So here's a mess called x plus h. So it's 2 parentheses minus 3. And what do I put inside the parentheses? That's right, we put in the x plus h. Okay. Now the form says minus, so minus, and because this is a quantity, parentheses, 2x minus 3, because that was the f of x. That's your f of x, 2x minus 3. So, all over h. So, this right here, don't get, oh my god, I don't know what he did. This, all of this right here is the f of x plus h, and then this right here is the f of x. That's all it is. And then we have h in the denominator from the formula. Now it's literally just an exercise in cleaning. This is the hard thing right here. Now we have to do the simplest form stuff. The simplest form is just your algebra to clean this mess up. Over h. What does the algebra tell me to do? Well, I got to distribute the 2. So that's pretty easy to do. 2x plus 2h minus 3. And now I distribute the negative sign. Minus 2x plus 3. And now what? It's just collect like terms. Well, look at this. 2x minus 2x cancel out. Whoa, that's not hard. Negative 3 and a positive 3. What happened? Oh my goodness, they cancel out. So what are we just left with on top? We're left with a 2h. What do we have on the bottom? H. So this big ugly mess, when we're all said and done, is this. Oh, wait a minute, what happens with those h's? We're left with a 2. That's it. So this big ugly mess, we're just left with 2. That's not hard. It's just fancy algebra. Okay. All right. Now let's look at the next one. So now my equations get a little bit harder. F of x is equal to 1 over x. We start off the same way. F of x plus h minus f of x all over h. All right, I'm going to start doing in my substitutions here. All right, I'm going to do my substitutions up higher so I can have more room to work, so I don't run out of room on my paper. Okay, so I'm going to do my substitution up top here. What's in the denominator? That's right, it's just an h. So my f of x, well, it's just literally 1 over, that's right, x plus h. 1 over x plus h minus 1 over x. All right, all I did was fill in my blanks. I filled in the blanks. Okay, so what are we looking at here? That's right, this is called a complex fraction. How do we clean up complex fractions? We multiply by the common denominator. What are the denominators? An x and an x plus h. So the common denominator is x times x plus h. This is why we have to know our complex fractions work. Multiply everything by the common denominator. I multiply the top, I'm going to multiply the bottom. Okay. Now, I am not going to distribute the bottom. I'm actually going to leave the denominator exactly the way I see it. All right, I'll just make it look a little bit prettier. So I'm going to write alphabetical order hx, or x, yeah, hx, and then x plus h. I'm not going to distribute this out. You don't want to. You'll just make your work harder for yourself. All right, now the top. What happens with this and this? Gone. So I'm left with 1x. What happens with the x's here? Gone. Now you're distributing a negative 1. So minus x minus h. And now look at the top. What do you notice about the top? That's right, your x's cancel out. So I'm left with a negative h over h times x plus h. And look at that. What happens to those h's now? They cancel out. So if everything on top cancels, you have your negative 1 on top. So this reduces to negative 1 over x times x plus h. There. All right, now, what does this mean in terms of a derivative? What I was talking about up here? So the derivative of this equation is just 2. The derivative of this equation, I'm going to show you, is equal to 1 over x squared, and I'm going to show you where that comes from. Okay? So in calculus, once you get down to here, you would do this next step. You would say the limit, LIM for limit, as h approaches 0. So as this h right here gets closer and closer and closer to 0, what happens to h? It gets smaller and smaller and smaller, eventually becomes a 0. So what do we have on the bottom? We're just left with an x. So the limit as h approaches 0 of this mess, negative 1 over x parentheses x plus h, is equal to negative 1 over x squared. Okay, that's it. So as h approaches 0, so as that becomes 0, we're left with just x squared on the bottom. So in calculus, we would say this notation, d over dx of 1 over x is equal to negative 1 over x squared. This is called the derivative. Okay, oops, I spelled derivative wrong, D-E-R. It's called the derivative. Okay, this is what we worry about. This is what you'll do next year in calc. If we have time at the end of the year, we're going to do this again, focusing on derivatives of limits. Actually, we're going to focus on limits. Okay, so that's all. It's just algebra. Straightforward as can be, simple as can be. Nothing challenging. The more challenging is because of the equations get more challenging. All right, now look at this one. 2x squared minus x minus 3. We're going to find the derivative. We're going to find the difference quotient, and then we're going to put it in simplest form. So f of x plus h minus f of x all over h. Give yourself a lot of room. You're going to need it. So x plus h. That's right, we fill in those two spots with an x plus h. So it's 2 parentheses squared minus parentheses minus 3. Then it's minus parentheses the 2x squared minus x minus 3. Remember, this was your f of x, and then this is your f of x plus h. And then what do I fill in those two spots? That's right, we fill in the x plus h. So now it's just a matter of cleaning this mess up. All right, we just got to clean this all up. Giving myself lots of room. All right, Gave myself, I didn't need all that mess. Oh well. So, to begin with, so it's 2 times whatever that thing is squared. Now I'm going to distribute the negative. Then I'm going to distribute the negative. All right. We've squared these tons of times. X plus h quantity squared. All right, so it's x squared plus, remember, x times h twice. Put it in alpha order. Plus h squared. Now I'm going to distribute the 2. And then I'm going to rewrite everything else. Ooh, I forgot to put my 2 here. And now we start collecting like terms. All right, what happens here? Oh, look at that. 2x squared and a negative 2x squared, gone. What? Positive x, negative x, gone. Negative 3, positive 3, gone. Ooh, I did another mistake. Mr. Prada, wake up. 2 times x, 2 times 2, and then 2 times the h. All right, that's better. All right, so now is there any other thing that we can combine or subtract out? No, so I'm just going to write things down. I'm going to put the, what am I going to do? I'm going to put the, I'll put the, I'll put it in proper quadratic form. So I'll put the 2h squared first. Then I'll put the plus 4hx. Actually, the order in which you write these things down does not matter. Minus h. All right, now look at this. What do you notice about all of that? Yeah, they all have an h in common, so I can divide everything by an h. So when I divide everything by an h, I'm left with, those h's cancel, that h cancels, that h becomes a 1. So I have 2h plus 4x minus 1. We have answered the question. Okay. Now, remember when I did that little limit piece in the beginning? So the limit as h approaches 0 of this mess is simply equal to, right, as h approaches 0, that just cancels out. That equals 4x minus 1. So this is the derivative of this expression. So the derivative, the d over dx of 2x squared minus x minus 3 is equal to 4x minus 1. That is called the derivative. In other words, it's called the slope of a curve. Okay? We don't need to do this. Your job is this. This is calculus for next year. Okay? This is your calculus for next year. All right. Last one. All that we're doing is the algebra. So we're going to do another difference quotient. So let's just start filling it in. So here's my format. So there's my x's. I'm going to fill them in with x plus h. All right. Yes, I know this is a mess. Okay. You're fine. You can deal with it. You're in pre-calc. So I'm going to rewrite this. I'm going to clean that up. All right, now, what's the common denominator? Right, the common denominator is just this and this product. Remember, we don't multiply anything out. We just write them out as a product. So it's 2 minus x times the quantity 2 minus x minus h. That's not hard. And then okay. So I'm going to take all this and do my work here. So the denominator we keep. Now the numerator, what happens? Right, these two cancel out. So I have to multiply those two. And then these cancel out. And we have to distribute a negative x to each of those. All right, so multiplying this part out, I have 2x, so 2 times x, 2x, 2 times the h, so plus 2h. Then it's negative x squared, and then it's negative, I'm going to put hx. I don't care that these are not in order, we'll worry about that after. Now I'm going to distribute negative x to all of those. So I have negative 2x, positive x squared, and then negative x times negative h is a positive hx. Okay? Now I'm going to collect my likes. The denominator we left alone. All right, what starts canceling? Well, this. A negative 2x and a positive 2x. A negative hx, positive hx. Positive x, negative x. Look at that. Oh my God, everything cancels out. I'm just left with what? A 2h. So out of this whole mess, this is it. We're done. Well, actually, we're not done yet because we got one more simplifying step. Right, your h's cancel out. So out of this whole mess, when we did this little fancy quotient rule, difference quotient, it all becomes 2 over 2 minus x times the quantity 2 minus x minus h. Really? That is pretty easy. Okay. That's it. And again, in calc, you would do, so the limit of this, so the limit as h goes to 0 of this quantity, what happens with the h? It disappears, so we're left with 2 over 2 minus x quantity squared. You're going to have fun in calculus next year. All right, that's our video on difference quotient. Nice, easy, a little bit of algebra fun.